In the following video lecture, we will guide you through of reading and interpreting technical drawings in the house factory. The foundation of effective work in both the house factory and on-site construction lies in the ability to read technical drawings prepared by designers. Although each designer may have a unique style, particularly in how dimensions are presented, it's essential to adapt to these differences, especially when dealing with drawings from different companies. There is no single universal type of drawing. Each drawing is, to some extent, factory-specific, based on how a particular factory is used to do it. Let's take a closer look at the production drawings of the external wall element and go through different parts of the drawing to familiarize with it. Standard drawings are typically on A3-sized paper, chosen for its practicality in factory environments where larger printouts are uncommon. The frame line defines the drawing's boundaries, with specific distances from the paper edges to prevent any issues when printed or binding the drawing to folder. Each drawing has a title block. The title block provides information about a particular drawing and makes it distinguishable from all other drawings. As a rule, the title block is designed by each company itself, and the information contained there is therefore also a little different depending on the needs of a particular company. However, there is a series of information that is usually contained there: project's name and number to which a given drawing is associated, name of the creator of the drawing. As a rule, the name and company of the creator is inserted here. This is necessary in case if any questions arise or additional explanation is needed. This information will help to find the person who made the drawing. Content of the drawing briefly indicates what is shown in the figure. For example, here, EW102 indicates that it is an external wall element number 102, page number. Sometimes there might be several drawings for a particular detail or element. For example, 4 drawings are required to construct an external wall element: 1 for the frame, 2nd for the additional frame, 3rd for the boards and the battens, and 4th for the cladding. The left number indicates the number of the drawing in the whole set of technical drawings, and the right number indicates how many drawings are in the whole set. Some other details are also included in the title block, like scale, date, and special amendments. Each detail in the element is assigned a position number for identification. If the details are exactly the same, then, as a rule, they are given exactly the same position number by the program. If there is some kind of a difference, then the number will also differ. If the specification is also displayed in the drawing, then only the details associated with the specific drawing are indicated. This means that only those details whose position number is visible in the drawing are listed under the specification. Specification list makes it easier to prepare materials and, if necessary, allocate only the materials necessary for the production accordingly this specific working section. In an element drawing, various views and sections like vertical and horizontal cuts may be provided. This helps to understand the assembly of construction details and elements. In the case of a horizontal section, the cut part is viewed from top to bottom, while in the case of a vertical section, it is viewed from left to right. Looking at the given drawing at the horizontal section, we see the frame posts and related wooden elements in brown. The section also includes the elements that this structure will come into contact with later. These are shown in black. The drawings of the additional elements can be found on the following pages. In any case, a 3D view helps to better understand a particular detail element, but in the case of very simple details, there is simply no need for this. Accuracy of the dimensions ensures each detail is correctly placed, and the precision is crucial for the assembly process in the factory. Therefore, it is important to keep in mind that each detail contained in the element gets in the right place, and the whole element remains within the tolerance limits of the specified dimensions. Let's take a closer look at the drawing measurements. Each element has three main measurements: the length, the width, and the diagonal. In several steps of frame assembly, it is crucial to check the diagonals of the element. During the assembly process, the diagonals might shift. Each producer has set specific tolerances for how much the shift is acceptable compared to the drawings. Usually, it is stated that the difference can be no more than ± 1 millimeter. Checking the diagonals is important to ensure that in the later stages of the assembly and on-site work, the elements will fit together. The following figure shows that the total length of the element is 4,155 millimeters. There is a measurement line for installing studs on the upper and bottom plates of frame. It shows where each stud must be placed. The first stud has a number 566. It is extreme and is located at the starting point, so-called 0 point. According to the material specification, we see that the first stud measures are 45 to 195 millimeters. The second stud after it, numbered 645, also has measures 45 to 195 millimeters, according to the material specification. Now, looking closely at the horizontal section, we can see that this stud is adjacent to the first stud, but rotated to a perpendicular position. The spacing of 195 millimeters shows both the width of the stud and the fact that the following, third stud, also numbered 566, is opposite the cross stud, and the distance from the starting point is 240 millimeters. The fourth stud, numbered 743, is located 490 millimeters from the starting point. Additional information required in the drawing is given either in text or in graphical form. This includes details about membrane overhangs, fasteners, and descriptions of the element's layers. Fasteners that are important for the load-bearing capacity of the structure are always indicated. For example, fasteners for stiffening plates, beams, angles, and so on. The information necessary for this comes to the compiler of the drawing from the engineer who performs the load-bearing calculations of the structure. In order for the element builder to have an overview of which layers the element must eventually contain, a description of the layers is also added to the element drawing. Here you see the layering list from external layers up to internal layers. UYSK is facade type, vertical and horizontal battens, wind barrier membrane, wind barrier board, insulation and frame, vapor barrier and additional frame. This list is important because no separate spreading drawing is made for membranes, wind barrier, vapor barrier, and in order for the membrane to be installed in the right place at the right moment, it is necessary for the compiler to know between which layers of the element it needs to be added. For example, in this drawing only the layers for framing, additional framing, wind barrier board installation, and vertical, horizontal roving and cladding is showcased. One of the most important things for the assembler in terms of constructing an element for the compiler is the understanding of the way in which the element is displayed for him in the drawing. This allows the assembler to mount the layers contained in the element on the correct side of the element. To facilitate this understanding, either an explanatory note, an additional sketch, or both should be attached to the drawing. In the case of the layout of an element between different drawings, it is important to take into account the technological order in which the element is assembled together. In the case of the external wall element, usually the work starts from mounting the room side of the element, which means that on the drawing you see room side layout of element. In this case, it is not necessary to turn the frame over in advance to install the next layer on the work table. If all the layers on the room side are compiled, then the element is turned over and the layers of the exterior side of the element needs to be installed. By understanding these principles, it is easier to understand more complex production drawings. Depending on the project size, is it a residential building or kindergarten, There can be hundreds of different drawings per project, and it is crucial to master the reading of technical drawings and be precise to follow it. It is essential for efficient and precise construction. A wall is much more than just something that divides spaces in a building. It plays several important roles that help make a building strong, safe, and comfortable. If you look at a building, then you see several different types of walls, and they are classified in two types: external and internal walls. Internal walls can be load-bearing walls, in meaning that they provide essential support to the building, distributing the weight from the roof and upper floors down to the foundation. Some internal walls are non-load-bearing walls that create separate rooms and areas within a building, separating two rooms or an entrance hall and a bathroom. Exterior walls are mainly load-bearing walls that protect the interior from weather elements, such as rain, wind, and temperature extremes. Usually, exterior walls are designed also to provide thermal insulation, keeping indoor spaces warm in the winter and cool in the summer. Some internal walls provide sound insulation to minimize noise transmission between spaces. Some walls are constructed to resist the spread of fire, providing crucial time for evacuation and minimizing damage. The simplest wall type is a non-load-bearing internal wall, as that doesn't have to withstand a vertical load. Vertical load is a weight or pressure that is applied from top to bottom. For example, the weight of snow applied to the roof of a building, or the weight of the ceiling applied to the walls of the room, or the load caused by people on the floor, and so on. As a rule, the inner wall frame is slender, for example, mostly made from 45 to 70 millimeter or 45 to 95 millimeter wooden beams, between which there is mineral wool for sound insulation, and the frame is usually covered with plasterboards, but wood-based boards can also be used. Little bit more complex construction than a non-load-bearing inner wall is a load-bearing inner wall. This might be the wall between apartments in apartment buildings, or the wall between the living space and the corridor, or the wall between classrooms in school buildings. Load-bearing inner wall has by default much more demanding requirements. It must withstand vertical load, and it has special fire resistance requirements. Within prescribed time, usually 60 or 90 minutes, the wall must not collapse in a fire situation, and it must maintain load-bearing capacity, as well as tightness requirements in terms of flue gases and temperature. Load-bearing inner wall needs to follow also sound insulation requirements. No one wants to hear our neighbors from the other side of the wall, and therefore the partitions must dampen the transmission of a noise. To ensure walls load-bearing, the frame must be made from strength-graded wood. Due to fire and sound insulation requirements, both sides of the partition can be covered with 2 or 3 layers of plasterboard. The most complex structure has the external wall. The construction of the external wall depends on the type of building. Is it kindergarten, private house, or apartment building? The technical solution is created by the engineers, which takes into account the requirements by the law and standard solutions developed by the specific house manufacturers. As a rule, the load-bearing frame of the external walls is significantly more massive than any other types of walls and may consist of several different partial structures attached to each other. Thus, the load-bearing frame may have a room-side cross-frame, which is designed to install additional insulation and create a gap for communications, like electrical cables. There may also be an external additional frame for installing additional insulation and wooden batten for fastening the cladding. The structure of the external wall also contains openings like doors and windows, for which separate spaces must be provided in the structure. The typical cross-sections of load-bearing timber frame for exterior walls are 45 to 145 millimeter, 45 to 195 millimeter, or 145 to 220 millimeter, but specific cross-sections are always specified by the designer. As mentioned, the wall elements can be produced in several ways, depending on their role and location. To better understand the drawings and the differences between them, let's go through the drawings of one external wall element and one internal wall element. This external wall element consists of 6 different technical drawings: drawings for the frame, additional frame, wind barrier board, vertical and horizontal timber batten, and cladding. These all are divided between 4 pages. However, the description of the layers shows more layers than provided in the drawings. It is crucial to check the description at the beginning of each new working stage to ensure no important elements is missed during installation. This also highlights the importance of following the technical order when assembling the element. What type of information we can see in the following technical drawings? For example, on the first stage of the assembly of element, looking at the first page of the drawing, the remarks on the left up corner are indicating that while installing the vapor barrier, make sure that the vapor barrier film overlaps the edge of the frame and openings by 200 millimeters, and all penetrations, like electrical or ventilation penetrations, through the vapor barrier should be sealed with tape. The second technical drawing, where installation for additional frame is showcased, we see some additional remarks for the vapor barrier. The drawing shows that there are some specific areas where no vapor barrier is needed. See that in written on the drawing. Accordingly to this, the vapor barrier needs to be installed from 2,045 millimeters up to 4,155 millimeters. The reason is this, that as this is a wet room wall element, then at the later stage, additional barrier is applied, and as 2 vapor-tight barriers are not allowed on construction, it might cause moisture issues. Then only one solution is chosen. Page 2.4 of the drawing shows the attachment of the additional frame to the main frame. The black dots here are showing the previous layer, and with green one, new layer installation is showcased. On the left upper corner, there are some new remarks as well. In this case, the additional frame needs to be secured to the base frame with a nail with the dimensions of 3.1 to 90 millimeters and with the step of 300 millimeters. When the worker has finished installing the additional frame as the last layer of inner side of the wall, the element should be flipped around, as external layers need to be also added. This is also the reason why in the page 3 and 4, when describing the board installation, and batten doesn't include 3D view sides as it was indicated at the first pages. Note that when flipping the element over on the work surface, the window location has shifted to the right side. Before assembling the wind barrier board, let's check the description of the layers. Is insulation installed correctly in the frame? If yes, the worker can continue installing the wind barrier board. In the drawing, we see that the wind barrier board, lines marked in blue, needs to be installed 292 millimeters over the one edge of the element. On the right side, there are once again specifications how to secure the boards and information regarding sealing the joints and sealing the penetrations in the boards with tape. Before moving to the next stage to install the vertical batten, let's check once again the layers, and there we see that wind barrier membrane is needed to be installed priorly. When continuing with timber batten, note how the wooden laths need to be positioned on the element. From below 11 millimeters is needed to go over the edge from the frame, and in the upper edge it goes over the edge of the frame 245 millimeters. In the horizontal batten drawing, we see that horizontal slats are installed 20 millimeters away from the left edge of the vertical batten, and at the same time in the right it goes 50 millimeters over the edge, and the first lath below is installed 11 millimeters from the edge, and the last one is secured on the wind barrier board, 132 millimeters away from the previous slat, or 175 millimeters from the edge of the frame. In the last drawing, we see the installation of cladding. A sharp eye can already notice that the cladding is also over the edge, from down 90 millimeters and from above with the offset of 245 millimeters. Below, right corner additional remark is made for the cladding, how to secure it, and how to cut it. In this case, the bottom edge of the cladding needs to be cut under 15 degrees, and the same cut needs to be done at the edge of cladding above window to prevent the moisture damages of cladding. Another thing to bear in mind, in the case of a vertical cladding, it is important to clearly understand the direction of the board's installation, from left to right or from right to left. The dimensions of the board are given up to the tongue of the board, because this measurement is reasonable to use when creating the element. It is convenient to align the edge of the board with the so-called tongue in the previously marked positions. When comparing the external wall element drawing with internal, then we see that the internal wall drawings are much simpler. Here you can see an internal wall element that has only two layers, one for the frame and other for the wooden boards. In this case, it's an OSB. Reading the drawing is almost the same. Follow the instructions on the technical drawings and carefully read all the remarks. Since internal walls cannot be easily distinguished by their inner and outer sides, an additional marking, called an arrow, is used. The view is marked according to the location of the arrow. In the horizontal section below, we see that not all beams are positioned on the ruler. In some cases where posts consist of several beams, only the edge of the beam is marked. There is no need to mark each beam separately, as they are tightly joined to the previous one. This approach keeps the ruler cleaner and makes the drawings easier to read. We cannot emphasize enough that there are tons of different ways how to build a wall element. Hopefully, these two cases already showed the principles of wall constructions and how to follow the production drawings to guarantee properly installed wall element. It is important to understand that each properly assembled element plays a crucial role in the whole construction. Not only that it's easy to assemble all the components together, but also provide safe, energy-efficient, and long-lasting homes. Now you are well prepared, so we can start introducing the assembly of the wall element. Priorly, let's check do we fulfill all the general requirements for factory work. The frame of the wall element is assembled on the work table according to the production drawing created by the designer. It is important to understand the drawings so that the frame can be assembled smoothly and accurately. If there are any questions or misunderstandings when examining the drawing, further clarification should be asked from the works manager, who can contact the designer if needed. Before starting to assemble the elements, it is necessary to visually check the quality of the material, as well as its compliance with the drawing. The timber material of the load-bearing structure must be strength-sorted and have a designation indicating the strength class. Usually it is C24. If the wood is visibly curved, has through knots or wane, then this material must be placed separately from the others, in a place designated for the defective material. To assemble the frame components, like studs, sills, lintels, need to be cut out according to the drawing of the wall construction specification. There may be several options here. One option is to order correct size components directly from the wood supplier, and other option is to use an on-site woodcut machine. But in the simplest case, the necessary details can also be cut out with hand tools. If an automatic machine tool is used, then the operator of the machine tool trained for this purpose is responsible for cutting the right amount and dimensions of the right parts. Each detail needs to be cut in given measurement ranges, tolerances that shouldn't be exceeded. In case of any deviation, it should be replaced. The measurements required for the component is entered into the woodcut machine. Some CNC machines are also capable of making markings for positioning or even mark the top and bottom plates, stud positions. In this way, it is not necessary to measure and mark the locations of studs later. On non-automated production lines, the dimensions of the stud locations are given on the assembly drawings, and they are marked on the top and bottom plates by the frame assembler. The pre-cut parts shall be placed on the worktop in the position shown on the drawing and accordingly the specification. With the straight edge, the flatness of the beams must be checked. The frame studs must be positioned between the web in fixed locations. To do this, pencil marks must be made in the correct places. If the locations of the wall frame studs have not been previously marked, then this must be done manually. The two webs, the upper and lower ones, must be placed side by side, the ends on one line, and mark at once on both sides of the wall frame the positions of the studs of the wall frame according to the drawing. If necessary, the brackets can also be fixed among themselves with lace screws to prevent them shifting. After marking the positions of the studs, a further check must be carried out to ensure that the positions are correct. Next, place the webbing on the work table and put the studs of the frame between the webbing in the marked positions, making sure that if the studs have holes drilled in them, they are on the right side position. Usually the wall structure has additional frame on the side of the room for the communications, but if it hasn't, then it is needed to drill the holes to the studs in designated places. As a rule, there are openings on the inner room side of the studs. Depending on the manufacturer, the frame studs are attached to the webbing by either nailing or screwing. The method of fixing must be in accordance with the assembly drawing or with the company's internal instructions. If openings are provided in the wall, like window, then between the frame studs you need to install intermediate beams that form the framework of the opening filler. After completing the assembly of the wall element frame, it is necessary to recheck the elements, the overall dimensions, diagonals, and positions of the structure must also be checked. Exact manufacturing tolerances are described in the company's system documents or agreed upon separately with the customer. The quality of nailing or screwing must be checked to ensure that nail or screw heads are not protruding. In the case of an automatic production line, the works are much easier. The assembly drawing of the element is already in the device in digital form, and the assembly of the structure is done mainly by the automated line, although some help is needed by the man for inserting the specific components and check the outcome. Some automatic lines are also capable of installing building boards on the frame. As automatic lines might be different and they require specific skills, then they are learned on site at the factory. After checking the measurements of priorly assembled frame element, it's time to start installing different building boards that can protect the construction from fire and give stiffness to the element. Boards that go on the room side of the element can be plaster boards or wood-based boards. There are also mixed solutions, where the wood-based board is under the plaster board, thus helping to stiffen the walls and make the wall stronger. And in case of exterior, wooden cladding, cement-based or composite material boards can be used as the outer layer. When it comes to external walls, in order to prevent the spread of moisture and air from the interior to the wall structure, a vapor barrier should be installed, which in most cases is a strong and age-resistant film. Installation and fixing of the vapor barrier must be carried out according to the solution of a particular project and the typical solutions of the company. In the following case, the vapor barrier is firstly secured with staples on the edges of the frame. To secure the barrier tightly, the vapor barrier film must be overhanging both at the edges of the panel openings and at the periphery of the perimeter. If there is a need to continue the film, then the film panes must be installed with an overlay and the continuation points must be sealed with a tape. Bear in mind that it is not allowed to install a vapor barrier film in the walls of damp rooms on which waterproofing is provided. Any excess material is cut off. As well, it also needs to be cut off around the wall openings, where windows or doors will be added later, and also secured with staples. If vapor barrier sits tightly on the frame, it's important to seal all the overhangings and loose ends of the barrier by using the tape. With this method, it is secured that no moisture gets inside the frame. Many house manufacturers use a solution where an additional lathing, for example 45 to 45 millimeters, is fixed to the load-bearing frame and vapor barrier between frame and laths. In such a case, it will later be easier to install an electrical installation on the wall like cables, straws, and sockets, without fear that the vapor barrier could be damaged. If the board coating is installed in an external wall that does not have an internal additional frame, then the vapor barrier film can be installed both directly on the frame or between the two layers of boards. First the lower board layer, then the vapor barrier, and the board layer on the room side of it. Before installing the boards, it must be checked that the boards are intact and free from defects. Defective boards with broken corners, cracks, chips, dents, or other defects should be separated and placed in designated area. The method of fastening the boards to the wall element depends on how many layers of boards will be used. As a rule, there are no more than 3 layers, however, most often they are limited to 1 to 2 layers of boards. The more board layers there are, the less often the step of fasteners, screws, of the lower board layer, since the fastening screws of the upper boards also pass through the lower board layers. Also, the spacing of the screws depends on their location. In the edge areas of the board, the step is less than in the central ones. Typical screw spacing for plasterboards are 200, 300, or 400 millimeters, more precisely. They are described in the relevant documents of the company. If it is a single-layer board coverings, for example, on interior walls, then for plasterboards, the standard screw spacing is 300 millimeters in the center of the board and 200 millimeters at the edges. Note that plasterboards must be fastened in such a way that the screw heads do not penetrate the cardboard layer and also do not protrude from the board. Plasterboard sheets are produced with a thinned edge at the long side. If a cut edge remains at the joints of 2 adjacent plasterboards, then in order for them to be puttied and finished later, the cut edges must be cut obliquely at an angle. Such a requirement applies to all layers of plasterboard facing the room, regardless of the number of layers of boards in the wall. In the case of a 2-layer board covering, the bottom board layer can be wood-based, for example OSB board. The fastening of the bottom board layer must be made according to the type of material, as well as the assembly solution of a particular project. It is important to pay attention to the places of the opening fillings, where later there may be a need to install a corner strip. In such places, it may be necessary to leave the step of fasteners larger. The spaces between studs are typically filled with insulation material. Depending on the location of the wall in the building, insulation materials can perform different functions, which are thermal resistance, fire resistance, and sound insulation. Mineral wools are mostly used as insulation materials, glass wool and stone wool. Both types of materials have different manufacturers and products, which in turn have certain specific properties. The main insulation between the studs is soft mineral wool with a lower density, while higher density rigid wool is used as the wind barrier covering the frame to protect the penetration of outside air into the main insulation. Other option is to use wind barrier plaster boards. During insulation work, gloves and a dust mask should be used, as insulation materials can irritate the skin and cause coughing and itching. As with any material, Insulation needs to be cut to the correct size accordingly the project. For optimal insulation of the element, the insulation material should fill all the space provided for it, leaving no gaps. In general, the dimensions of the insulating material are 5 to 10 mm larger than the filling hole to fit snugly against the structure. In order for the insulation to correctly perform its function, it is necessary to avoid the formation of gaps. If the insulation is laid in several layers, it must be ensured that the joints between the insulation are not in line with the joints of the previous insulation layer. The wool must uniformly fill the entire frame gap. If the technology requires that one side of the wall element remains uncovered by boards in the factory, then securing cords or wires are used to fix the insulation in place. In the walls between different fire zones, for example the walls between the apartments, the insulation must provide protection against both fire and noise. Each building has a certain required fire resistance time according to its size and security requirements. Most often it is either 60 or 90 minutes. The required time is achieved through the interaction of wood construction, insulation, and board covering. Quite often, there is a need to flip over the frame element after completion of certain works, so that the subsequent work can also be done from the other side of the element. For example, if the structure is assembled, insulated, and covered on one side with building boards, then by turning over, the work on the workbench can be completed by installing layers of boards on the other side. There are two ways to turn over: either lift the elements with a crane or use the so-called butterfly tables. Crane lifting is relatively slow and requires several people to work together. That is why many manufacturers use butterfly tables. This means that two adjacent work tables that can be lifted by their edges so that in a vertical position they meet, and the finished structure moves from one table to the other in a turned position. To protect the insulation from the penetration of outdoor air, a wind barrier must be installed. Wind barriers are typically made of mineral wool, wood-based materials, gypsum board, or synthetic fabric. Wind barriers are durable, weather-resistant, and designed to withstand wind and moisture loads. The wind barrier is installed on the exterior wall element, over the insulation, and under the exterior cladding battens. It is securely fastened to the frame. The wind barrier prevents the movement of outdoor air and moisture into the construction and, if necessary, allows any moisture from inside the wall to escape. When assembling a wall element, it should always be considered that it may be necessary to integrate communications, electrical cables, ventilation, sewerage, and water pipes into them. Where and what communications need to be installed, it depends on the specific design solution and is indicated on the corresponding production drawings. As one of crucial working stages in the whole element assembly processes is lifting the element, then these works are carried out by specially trained and licensed employees. And in some factories, special transporters are being used to transport and lift the elements in designated area for further working stages. When done it correctly, it will not damage the previously assembled and finalized element. If the assembled frame is lifted with a crane, additional holes must be drilled into the top and intermediate joists, and lifting straps must be installed through them. The lifting straps and their locations must take into account the weight and weight distribution of the structure, and in the case of heavy elements, if necessary, the opening must be strengthened according to the working drawings. Most often these are company-specific solutions. When lifting elements, a spreader beam is usually used. A spreader beam is a metal structure used as an aid in lifting operations to ensure that the lifting straps attached to the frame are straight and do not deform the structure during lifting. It is crucial to strictly adhere to all safety requirements during lifting operations. Floors do much more than just provide a surface to walk on. They play a crucial role in the overall function and comfort of a building. First, let's talk about the primary function of a floor. It is to support and distribute the load. Floors are designed to support the weight of people, furniture, and other objects, distributing the load evenly to prevent any structural damage for the building. Floors also play a key role in insulation and energy efficiency. An insulated floor helps maintain a comfortable indoor temperature, reducing heat loss in the winter and keeping things cool in the summer. Another important role of floors is sound insulation. Soundproofing materials in floors help minimize noise transmission between different levels of a building, creating a quieter and more comfortable environment. In multi-story buildings, floors also act as fire barriers, helping to prevent the spread of fire between levels. Fire-resistant materials and proper construction techniques can provide valuable time for evacuation and reduce damage during a fire. Modern floors can also integrate advanced technologies like underfloor heating to enhance comfort and efficiency. As usually, underfloor heating has been used mainly in the wet rooms, like bathrooms, then more and more we see underfloor heating also in other living rooms, providing a cozy atmosphere without the need for radiators. In summary, floors are a vital component of any building, offering support, insulation, soundproofing, aesthetic appeal, fire resistance, and even advanced comfort technologies. So next time you walk into a building, take a moment to appreciate the floor beneath your feet. It's doing a lot more than you might think. Just like there are several types of walls, there are also several types of floors. It all depends where are they located and what is the main purpose of the floor. Typically, we are distinguishing two types of floors: first floor floor and intermediate floors. Quite often, first floor floor is also the ground floor and is the lowest floor of a building, situated at or slightly above the ground level. It might be directly connected to the building's foundation, but most importantly, it provides a base for the entire building structure. As being the lowest floor of a building, it also requires significant insulation to prevent heat loss, and moisture proofing is crucial to prevent any moisture from entering the building. Intermediate floors are any floors situated between the ground floor and the topmost floors. The intermediate floors are designed to distribute loads efficiently to the building's structural framework. Compared to ground floors, thermal insulation is less critical, but it requires insulation primarily for soundproofing between the floors. Therefore, first floor floor differs significantly from intermediate floors, and the construction materials may also vary. And for the assembly of a specific element, it is necessary to carefully study the detailed instructions, both the corresponding work instructions and the production drawings. The floor structures of factory buildings can also vary considerably, depending on whether they are element or modular buildings. For instance, in the case of modular buildings, the intermediate floor is divided into two separate parts: a floor panel and a ceiling panel, but in the element buildings, it's a single integral panel. Floor elements can have several special features that are reflected in the production drawings. The fastening methods for the beams may vary, and the elements may have openings for both lift shafts and staircases. In addition, various technical installations may also be located in the floors, depending on the floor element location in the building and its purpose. Now let's look at the floor element drawing. Here is shown the intermediate floor drawing, and at first it looks quite similar to the wall element drawing, but still some specific details have been changed. For example, some new additional details have been put on the drawing. Current floor drawing is consisting of two layers, one for wooden frame and other for particle boards. Let's start from the first drawing, assembling the wooden frame. On the left up corner, you see from what side the view of the drawing is. For instance, in this case, the view is from the above, as the next layer is constructed on the top of the element. Also, you see additional remarks that are related to fastening the beams and fixers. There is also additional sketch for showcasing how to fix beam shoe, as the fixing system can be different depending of the project. Beam shoe helps to connect beam with other structural component. It provides support and stability for the beam, helping to distribute the load weight that the beam carries. As designer has made the calculations for load bearing and has chosen the most suitable way how to fix the beam shoe, it is important to follow the additional scheme. In this case, partial nailing is needed. The blue dots show where the nails should be added. On the right upper corner, you see the material specifications. Since some of the beams need to be cut additionally, then here are added references to the drawing accordingly it needs to be done. Let's see what needs to be done accordingly. The page 2. Here it is, showcase the drawings of adding the particle board. Its main aim is to take the load and give additional stiffness to the element. Under the remarks, it is written how to fix the particle board. Accordingly, it is needed to fix with screws with the screw dimensions of 4.2 millimeters, and the length of the screw should be 55 millimeters, and the step between the fixing points on the particle board should be at least 200 millimeters. But also note that glue is required. This means that before fixing the board with screws, glue needs to be applied to the board, and afterwards it needs to be additionally fixed with screws. Note that on the drawing, the particle board location is shown with green and is numbered according material specification. From the right side of the element, you will see that some parts will not be covered with particle board, and this is how it should be left. Before starting to assemble the frame of the floor element, the components for the frame must be prepared in the same way as for the wall element. Since floor elements may be designed to bear higher loads, special solutions and materials, such as wood-based I-beams, also known as I-joists, might be used. The unique I shape of the beams, with a vertical slim wood-based web connecting two horizontal flanges made of either solid wood or plywood, provides excellent strength and rigidity. This design helps distribute weight evenly and reduces bending. I-beams can span longer distances than traditional solid wood joists without requiring intermediate supports. This allows for more open floor plans and reduces the need for load-bearing walls and columns. I-beams are manufactured to precise specifications, ensuring consistency and uniformity in construction. This helps maintain level and stable floors, reducing the chances of uneven or squeaky floors. For constructing a floor structure with I-beams, the house manufacturer's work instructions must be in precise accordance with the beam manufacturer's guidelines and requirements. Using such beams involves many specifics, especially in making joints and drilling openings. The process of assembling the framework of a floor panel can differ significantly in various factories, in terms of both the materials used and the operational steps. Floor element assembly is mostly done by hand, as the use of automatic lines is less common in this context. This is due to several time-consuming operations that automatic lines typically do not perform. These are mostly related to wet areas like shower rooms and bathrooms, whose floors require different technical solutions than those of dry areas like living rooms. Additionally, the installation of heating systems and the upper layers of the floor inevitably has to be done manually. Let's carry out the following floor assembly process steps based on the intermediate floor for the module. The assembly of the frame is preceded, as always, by preparing all the materials. If cutting the frame components, then do it according to the material specification. The table specifies the dimensions of the components and the quantity of pieces. Cutting is done either using an automatic machine or manually. Then, the framework is assembled on the work table according to the drawings. For assembling the floor framework, both solid wood beams and wood-based I-beams are used. Hybrid beams, where the beams are tied together with a metal framework, are less common. If there are no machine-tapped pockets for intermediate beams on the edge beams, the locations of the intermediate beams must be marked on the edge beams before assembling the framework. This should be done for 2 beams at a time, using a sufficiently long measuring tape and a square. Edge beams should be placed on the table in such a way that the intermediate beams fit between them. The intermediate beams should be positioned according to the previously marked lines. Next, the beams are fastened together, either by nailing or screwing. The sizes, types of fasteners, and methods of attachment are described in more detail in the manufacturer's work instructions, which must be followed. Depending on a project, reinforcement boards can be attached to the intermediate beams. Reinforcement boards are special wooden components made from plywood or other strong wooden-based material to make beams stronger and more rigid. And as the last step for assembling the frame is to check the flatness of the entire construction with a straight edge. There should be no steps at the joints. The dimensions must be checked for compliance with tolerance requirements. Remember that different manufacturers may have different tolerance requirements. Generally, the requirements are written in the working manual or specified in the drawings. In previous videos, we showcased how to assembly I-beam floor element. Wooden beam floor panel assembly is somewhat simpler compared to I-beam floor panels. However, the general principles are similar. The process of assembling wooden beam floor panels is easier as it is not necessary to install reinforcement boards between the beams, and the beams can be directly nailed to the edge beam. In cases of larger loads, beam shoes can also be used. If there is a need for a stiffer structure, double wooden beams, custom-sized glued laminated beams, laminated veneer lumber or engineered wood, or steel beams can be used, especially for large openings. Other tasks related to tolerance measurements, flatness, plumbing, insulation, or floor covering installation do not differ significantly from the tasks performed when assembling wooden beam floor panels. So, in overall, the process of assembling wooden beam floors are the same as with I-beam floors. In some cases, like in element buildings, where the floor and ceiling is a single element, the order of operations may differ from that of modular house floor elements. Therefore, it is needed to follow the instructions based on the drawings. The floor of the first floor, however, is mainly based on an insulated concrete slab. For floors that are ventilated from below, a wind barrier must be added. Usually, it is a wind barrier gypsum board, a mineral wool wind barrier board with wind barrier fabric, or a cement-based board. In the case of wind barrier fabric, the joints of the barrier must be taped with designated tape. To prevent damages caused by rodents, metal meshes or grates are used in front of the ventilation openings in the foundation. As in this video, we are showcasing the floor for modular building. Then here you see how additional support beams are installed. These are for transport, on which the volumetric element rests when it is stored or transported by truck or ship. The installation of transport beams must be done according to the solution developed by the company, as described in the work instructions. For example, in element building, it might not be needed to add, therefore always check the drawings and guidelines provided by the company. Once the floor panel is assembled and the work on the bottom side is completed, the floor element needs to be turned over to continue the works on insulating the panels and covering them with boards. After the floor framework is flipped, the next steps include installing any necessary plumbing into the structure and integrating a specific floor section for a wet room, if one is present, into its pre-prepared location in the structure. Many manufacturers assemble the wet room floor later, after the room element is completed. When installing plumbing, it is essential to follow the fixing solutions developed by the company. These should ensure that the plumbing is securely fixed at the prescribed intervals. Water pipes must be installed and secured in such a way that it's possible to replace the pipes inside the casing if needed later. If there are pipe penetrations in the floorboard, then the board needs to be milled for an opening with a diameter approximately 20 millimeters larger than the pipe or pipe bundle. The pipe penetrations are later sealed with the designated sealing compound. The sides of the shaft openings in the floor panel, in the case of multi-story buildings, should be constructed according to the project documentation, typically using plasterboard, and the joints are sealed with fire-resistant sealant. In case, when a specific floor section for a wet room is included in the assembly, it should be also installed. Some companies, especially on modular building case, are preparing separately wet room floor sections with the required floor slopes and heating system in the floor element. This kind of solution will later help to speed up the work done in the module. Floor insulation begins with checking the dimensions and flatness between the beams. This means that before insulation, it is necessary to ensure that the structure meets the specified dimensions. The insulation between the beams must fill the gaps evenly and tightly, without any voids, creases, or folds. If the insulation consists of multiple layers, the joints between the layers should not align, but should be offset by at least 100 millimeters. A common mistake is to press the insulation down at the edges, causing it to sag. In such cases, the insulation should be slightly pressed in the middle and the edges pulled up to the same height as the beams. Before installing the floorboards, it is necessary to once again ensure that the dimensions and diagonals match the project specifications. Subfloorboards are typically made of plywood, veneer, or OSB boards. The attachment of the boards is carried out according to the work drawing and a pre-developed standard solution. The boards are glued to the beams, and for fastening, either nails or screws are used at designated interval, usually 150 to 300 millimeters. As the board is covering the beams below, it is smart to mark the beam's location on the subfloorboard, so it's easier later nail the boards into the beam. The heads of the fasteners must not protrude above the surface of the panel or be recessed into the panel. The boards are usually joined with a tongue and groove connection, except at the edges where the boards are cut to size. The cross joints of boards rows should not align with each other. Depending on the manufacturer and the type of boards, it may be possible to leave the board's end joints between the beams if there is a corresponding tongue and groove connection provided by the board's manufacturer. After installing all the boards, the entire floor's levelness must be checked. In element buildings, the intermediate floor is a single integral panel. The intermediate floor serves two functions at once, as the floor for the upper level and the ceiling for the lower level. However, in modular buildings, the intermediate floor is divided into two separate parts, a floor panel and a ceiling panel. For modular buildings, a metal mesh or wood-based board is typically installed on the floor panel to support the mineral wool between the beams. In element buildings, the lower layers are made up of battens. Depending on the project and the size of the intermediate floor element, the board layers that form the ceiling of the lower floor can be added either in the factory or after the element building has been erected. Europe aims to reduce greenhouse gas emissions by at least 55% by 2030. One key strategy is to improve the energy efficiency of existing buildings through renovation. Europe's renovation wave strategy plans to renovate 35 million buildings by 2030. To meet this ambitious goal, innovation in renovation techniques is essential. Traditional methods, such as foam installation and on-site plastering, are time-consuming and disruptive for residents. As a result, there is a growing demand for faster and more efficient renovation methods. One promising solution is to manufacture insulated facade elements in factories and then attach them to existing buildings, much like putting a coat on the building. This modern renovation method requires advanced digital capabilities, particularly for scanning buildings that need renovation. Although many buildings are constructed similarly, time has affected their quality, leading to variations. For example, windows may not be aligned or uniformly sized. Scanning technology provides a detailed overview of the building's current condition and parameters. This data is crucial for engineers to design effective renovation solutions. Once the design is finalized, the process is similar to other industrial methods. Engineers create production drawings, and the elements are manufactured and later attached to the building. Now, let's take a closer look at the product drawing of the facade element for renovation. The product drawing shows that it is quite similar to any other external wall element. However, the specific design and materials used depend on the architectural and engineering requirements of the project. One significant difference in most renovation projects is that these facade elements often have an integrated ventilation system. It is important that after insulating the building, proper ventilation is provided. As building becomes more airtight and without proper ventilation, the indoor climate becomes bad and unhealthy. The room air becomes more humid and the amount of carbon dioxide increases. Therefore, the ventilation system is the main difference between typical external wall elements and facade elements used for renovation, and its purpose is to reduce risk of moisture accumulation and improve buildings' indoor environment after renovation. As with any construction project, begin by preparing all necessary materials and tools. Ensure everything you need for this phase is available. Once you have everything, start assembling the timber frame according to the production drawings. In this particular case, since the ventilation pipe is included, some timber components will have cutouts to accommodate the pipe. After assembling the frame, recheck the dimensions of the entire structure, just as you would with any other frame. Now it's time to install the insulation and ventilation pipes. First, add the insulation, ensuring it adheres tightly without any gaps, voids, or wrinkles. Next, place the ventilation pipes on top of the insulation. To prevent the wool from deforming, make additional cutouts in the insulation where the pipes will sit. After the insulation and pipes are in place, it's time to add the vapor barrier. Secure the vapor barrier around the entire edge of the element, making precise cuts for the ventilation pipes to pass through. Use tape to secure the vapor barrier around the pipes and between them. Ensure there are no gaps between the frame and the ventilation pipes to prevent any air leaks. If vapor barrier is firmly attached and secured, turn the element over and check that the element meets the established tolerance requirements through measuring the dimensions of the element. If the diagonals meet the requirements, proceed with the next steps. Adjust the insulation edges to be flat with the frame. Carefully attach the wind barrier panels to the frame, ensuring they are aligned and maintaining consistent gaps between them. Regularly check the alignment while securing the panels and cut off any excess material. Next, apply an adhesion improver to the gaps between the panels and around the open edges. This will help secure the sealing tape and insect net tightly. The insect net is crucial to prevent insects from entering the construction of the frame. Since the facade covering will be placed on timber laths, the insect net should be secured where air flows behind the lining. Therefore, ensure the frame is air-sealed tightly by securing the tape with spatula. Before installing the facade, secure the exterior windowsill to prevent water from dripping under the facade. Next, attach wood slats to the wind barrier board. Note that the slats need to be secured on point. Ensure the slats are precisely secured, fixed. Wrap and secure the loose ends of the previously added insect net around the slats. Perform a final check to ensure everything is properly installed and secured, preventing any moisture or insects from entering the construction. Once confirmed, you can begin assembling the facade panels. First, make sure the facade panels are cut to the required size. Align the panels on the element and start fixing them. Ensure the panels are symmetrically aligned and the gaps between them are consistent. You can use special boards to ensure the gaps between each panel are exactly the same width. With the element nearly complete, only the windows and compensation wool need to be installed. Before proceeding, conduct a quality check to ensure that the window units and glass surfaces are undamaged. When installing the window in the facade element for renovation, follow the specific guidelines provided by the window manufacturer, just as you would for a typical external wall element. Pay special attention to taping the windows to prevent any water and air leaks. Once the window is installed and sealed with foam or mineral wool, perform a quality check of the sealing to ensure it is secure. Next, add window trims as a finishing touch. Be cautious when cutting sheet metal trims, as the material can be very sharp. Finally, add to the inner side of the element compensation wool to ensure maximum efficiency of the element. Position the wool on the wall element by ensuring that it covers the intended area without any gaps. Secure the wool using appropriate adhesive or mechanical fasteners, and make sure it is firmly attached and evenly distributed. Trim any excess wool and make any final adjustments to ensure the wool is properly installed. Perform a final inspection of the element. Ensure that compensation, wool, windows, and exterior finish is installed correctly and secured in place, and the element is ready for packing.